Hello, everyone. Welcome once again to another session of pre-calc. Today we'll be discussing representation of functions and, more importantly, transformation of functions. In terms of representing functions, we must recall four ways of doing so. The first one is written verbally, such as writing out the words y is proportional to x squared. The second way is algebraically, such that let's write the letter y equals 2x squared. The third way is by writing out a table of values with x and y. And if we're doing for y equals x squared, we'd like to probably just pick some numbers like -2, -1, 0, 1, and 2. And then for the y value, we square each of the x values. So we map -2 to 4, -1 to 1, 0, 0, 1 to 1, and 2 maps to 4. We can take these and do another representation, which is a graphical representation, where we plot the x, y, and values as coordinates with your x's on the horizontal, y on the vertical axis. And so we plot the points -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4 on the graph. And then we can draw a smooth curve through all these points, and that will give us our graph. Now let's talk about transformation of functions, or transforming functions. Recall, for a function, one input has exactly one output. Particularly, the input must be valid. We can have algebraic operations on numbers and functions which return numbers. So a given function, a of x, on this, we can build to get another function, let's say m of x. For example, m of x can be equal to a of x plus 1, which is a new function. Let's see what does adding 1 to an original function does. Imagine that a of x is a function passing through points 0, 4, 1, 2, 2, 2, and 3, 1. Then m of x being equal to a of x plus 1 is a function passing through the points 0, 5, 1, 3, 2, 3, and 3, 2. Look what happens. Notice that there's a shift in the graph of 1 unit upwards, where the a of x points were the green dots and the m of x points were the black dots. Notice all the dots are shifted 1 unit upwards. Let's look at a more concrete examples. Let's look at some more examples. Let us say g of x was equal to root x. So g of x right here is our green curve. And let's say g of x plus 4, which was h of x. So h of x would be equal to g of x plus 4. Now notice what happens. The g of x function is shifted up 4 units. It's shifted up 4 units to get to h of x. Shifted 4 units up to go to a of x, to go to h of x, right? And if k of x is our black graph here, k of x is our black curve, and it is g of x minus 4. Notice here your g of x is shifted 4 units down. It's shifted down 4 units. 4 units. If we continued exploring this with other functions, what we will eventually do is make a conclusion about what happens when we add or subtract numbers from an original function. And a conclusion we will most likely make, or we will make, is that the graph of y equals f of x plus k is shifted upwards k units, where k was a number like 4 in our original, or in our previous example, shifted up k units, right? And the graph of y is equal to f of x minus k is shifted down. It's shifted down k units, right? So it's shifted down k units. That is what we call a vertical shift, or a translation of the graph. Let's look at another example. Suppose we had a graph f of x was equal to root x, represented by this purple graph right here, and g of x was root of x plus 1. G of x is our black curve right here, and notice what we have happening is that this is a shift of the original graph left by 1 unit, right? So g of x, radical x plus 1, shifts the original function f of x 1 unit, and then h of x is our red graph, and notice here what it does, it shifts the original function right by 3 units. So notice what happens when we are subtracting in the domain, performing a function transformation of a minus, then there's a shift to the right, right? There's a shift to the right, and when we have a plus, there is a shift to the left. So we could continue doing that with some other graphs, and then make a general conclusion that in general, the graph of y is equal to f of parentheses f x plus h is shifted left by h units, right? It's shifted left by h units, and then the graph of f of x minus h is shifted right. X minus h is shifted right by h units. Shifted right by h units. This is called a horizontal shift, or translation of the graph. So look at the third kind of example. In this case, we're looking at the graph of f of x is equal to x squared. F of x equals x squared. And then look at g of x. G of x is our black curve here. G of x is equal to 2 times x squared. And then h of x is equal to 4 times x squared. H of x equals 4 times x squared. And notice what is happening. Let's look in the vertical direction what is happening, because we're multiplying the original function by different numbers bigger than 1. So in the original function, let's say we're looking at what happened at the point where x is equal to 1. 1 was mapped to 1, but when you multiply the original function by 2, notice this one is mapped to 2, so we are stretching up. And again, when we multiply the original function by 4, this 0.11 goes up to 1,4. So what we having happening here, if we continue doing that, we would conclude that the graph of y is equal to a times f of x is stretched vertically if a is greater than 1. And if we looked at some other examples where a was between 0 and 1, where a was between 0 and 1, we would have found that the graph was shrinked. The graph was shrinked vertically, right? If you're multiplying the function by some fraction, it will be shrinked vertically, right? Let's look at another kind of transformation. Another kind of transformation is, for example, when you have f of x is equal to x cubed, is equal to x cubed, and let's say we had g of x was, in parentheses, 2 times x cubed. That will become this black graph here. G of x is equal to 2 times x. Notice the 2 and the x are in parentheses, cubed, and then another one where h of x was equal to 4 times x in parentheses cubed. Now notice what is happening in the horizontal direction. Notice what is happening in the horizontal direction. Horizontally, what is happening is the curves are getting closer and closer to the y-axis. So what we're having is a horizontal shrink of the curves. All right, and notice the numbers here are bigger than 1, 2, and 4. They're bigger than 1, so we can make a conclusion that the y is equal to f of a times x is shrinks horizontally, is shrinked horizontally if a is greater than 1. And the opposite would happen. The graph would be stretched horizontally if a was between 0 and 1. So it's like opposite of what is happening with the vertical stretch and shrink. Okay, and these are, when you multiply by the x values by numbers, then you have a stretch or a shrink along the domain values. Okay, let's look at another type of transformation. Look at the graph of f of x is equal to x squared, and that's here in purple. F of x is equal to x squared. And the graph of g of x is equal to negative x squared. Notice what is happening. The graph of g of x is equal to negative x squared is a downward sloping parabola, while f of x is equal to x squared was an upward sloping parabola, where they meet at a point 0, where the minimum of f of x was 0 and the maximum of g of x was at 0, 0. It looks like it's flipped over the x-axis, and that is true. So we can draw a conclusion here that y equals negative f of x, y equals negative f of x is a reflection of the graph of y is equal f of x through the x-axis. Notice it looks as if we are actually doing a flip or reflection over the x-axis, right? The final transformation that we shall look at is given a graph of f of x is equal to root x. That is, f of x is equal to root x. This is a red curve right here, x, and g of x is equal to root or radical of negative x. Radical of negative x. Notice it seems as if the red curve is flipped across the y-axis. So red curve is flipped across the y-axis. The y-axis. So the graph of y is equal to f of a negative of x is a reflection. It's a reflection of the graph of f of x through the y-axis. Okay, a reflection of the graph of f of x is equal over or through the y-axis. All right, don't forget to like and subscribe, and see you next lesson.